All right, we'll talk about, first off, we're going to talk about sequences. There is a difference between sequences and series. Sequences basically talks about a list of all the numbers there is. A series usually means we're taking all those numbers and adding them up. Okay, so there is a difference between the two words. Just make sure you know a little difference on those. So when you hear the term sequences, you probably think about sequences of events, what happens first, second, third, so forth, and so on. In mathematics, the term sequence deals with outcomes that are first, outcome that's second, and so on as well. In dealing with sequences, we subscript letters. A sub 1. The subscript, guys, represents what term number you are on. Please know that. The subscript will represent what term number you are on. So A sub 1 represents first, A sub 2 represents second, so forth and so on. So it says, go on and says, given the sequence 2, 5, 8, and 11, what is A sub 1? A sub 1 is going to be our first term, which is 2. Good. A sub 2 is 5. Second term, that's a D. Third term is 8. And then finally the last term is 11. So as you can see, those subscripts is really important to notice where they are, because sometimes we can ask questions that says, what is A sub 6? Well, you need to know we're asking for the sixth term of the sequence. Okay? So it goes on here, it says expanding a sequence. So writing example 1, write the first several terms of a sequence in here. So write down the first 6 terms of what we need to find. So we're going to go all the way to A sub 6. And so what you go through and say, all right, A sub 1. Well, look at the equation. What do you think N is represented by? What is N? The term number. So the very first term, N is going to equal 1. So you take the equation, 1 minus 1 divided by 1. You simplify that and you get 0. A sub 2 means now that N equals 2. And now you're left with 1/2. A sub 3 means N equals 3. 2/3. I think you guys are getting the idea here, right? Keep going. Let's stop at A sub 5 and A sub 6. You get the idea of how to plug it into the equation now and get your answer. However, let's stop doing that. What's going on the top every single time we go through? Yep. The denominator and the numerator are related because the denominator keeps moving up by 1. How is it related to the numerator? It's 1 less, right? So what's going to be A sub 5? 4/5. Then find the last one's going to be 5/6. Once you do a few of them, you can see the pattern and just follow that to finish it off. Okay? Moving on to the next example. So it says write down the first 6 terms of this one as well. This is going to be a little bit lengthier, so you might not have enough room here. I know I won't. So my first term is going to be -1 raised to the 1 plus 1 power times 2/1. We've plugged in what term we're on and substitute that in for the letter N, or variable N. And now we're going to go ahead and simplify this. So -1 raised to the 1 plus 1. That's -1 raised is squared. What's -1 squared? 1, right? Times 2 divided by 1. So you end up just getting 2, right? Okay? Now things get a little bit different. Now we're at the second term. 2 plus 1 over 2 over 2. What is negative 1 raised to the 2 plus 1 power? It's 3, so what's negative 1 cubed? Negative 1. And then 2 divided by 2 simplifies to so when you plug it in and simplify, guys, we're looking at negative 1 raised to powers, which we know that means it's either going to be positive or negative 1, right? Then you're taking 2 and just dividing it by whatever term you're on. Let's go on to a sub 3. So negative 1 raised to the 3 plus 1 power gives you what? Positive 1 times, does 2/3 simplify? Nope. So 2/3. Let's do one more and see if we can find a pattern that's going on here, guys. Negative 1 to the 5th is? Negative 1. Josh is killing it today. 2 over 4 reduces to what? Oops, forgot the negative. Thanks, Trent. Is there a pattern here? Pete says yes. It's getting smaller. Okay. By? It's hard to tell, isn't it? It is kind of hard to tell in this one. What is the one thing that's obviously happening, though? Don't focus on the number. Maybe focus on the sign. It's alternating, isn't it? So that means my next answer is going to be what? Negative or positive? Positive. So my A5 is going to be positive. So I'm going to go ahead and write A5. It's positive. So I don't need to put anything there. Let's figure out what's going on. Look at the second set of parentheses. It's 2 over what? 2 over n. N represents what, guys, when we're dealing with sequences? The term. What term are we on right now? 5. So this answer will be positive 2/5. All right. What about the last one? Negative 2/6. Well, or... So if you think about it, guys, we simplified everything, right? But let's go back and look. Look at those numbers I just written in. 2 over 1, 2 over 2, 2 over 3, 2 over 4, 2 over 5, 2 over 6. Easier to see when you don't reduce, guys. I'm saying this for this reason. You're going to have to do this backwards. You're going to have the terms. They're going to give you all the terms, and you got to come up with the equation. Sometimes they give you reduced fractions. If that's the case, you probably need to go in and make them all have the same denominator or try to make something match on. In this case, it's the same numerator. And guys, that's just doing practice. That's just doing trial and error and trying to make it match. But once I put them now in their non-reduced or improper form, 2 over 1, 2 over 2, 2 over 3, 2 over 4, 2 over 5, 2 over 6. Now you can see the pattern a lot easier. It's really hard to see 2, negative 1, 2/3, negative 1/2, 2/5, negative 1/3. That's hard to see, the pattern there. You can't see it. So just saying, for help, make sure sometimes you look at that. Okay. CP stands for class practice. That's you guys. So you go ahead and give it a shot, guys, and see what you can get for the next 2 problems. Substitute it in. Reduce if you have to. All right, guys. How do we do? What do you notice about the pattern of numbers in the first class practice 1? What do you notice about the numbers there? Plus 2 every time. Where's 2 located in the equation? Front. What did we usually call that back in Algebra 1? Huh? Close. That word is involved. Yeah? Slope. Slope. What's another word for slope? What's another term? Not word. What's another term for slope? Word constant's in it. Constant rate of change. Would you agree that those red numbers along the left side there have a constant rate of change? What is that constant rate of change? We're back at 2 again, right? So as you can see, guys, with this called sequence, you're still dealing with linear functions. You're still dealing with a constant rate of change. You're still dealing with slopes. All right? Move on to the next one. Is there a pattern there that you see, guys? Thanks. I'm sorry, I'll say it again. Times 2, it's doubling every time, isn't it? Where do you see 2 in the equation? In the middle. It's actually the number that's being raised to a power, isn't it? It's being the one that's raised to an exponent. It should look very familiar, guys. You just had a test over it. Every time I'm including one more 2 into my multiplication. So that means times 2, times 2, times 2, times 2. Constant rate of change. That's a constant ratio change. Constant ratio change. All right? All right, let's move on to the next one. Did you guys do this one yet or not? No. You don't even know. What was it, Trent? You didn't know it was there? Whoops. I'm going to stop right there, guys. I've gone the first 3 terms of it. I know fractions is an F word for y'all, but we got to deal with them, okay? So, what do you notice is being done here? Now, use something we just talked about just prior to maybe helping you out what we're doing here every time. Multiplying the answer, previous answer, by 2/5. Right? Look what's in parentheses. 2/5. Is that being raised to an n power? Granted, it's n minus 1, but it is n. What happens when I keep going along in my sequences, my terms? What am I doing with my term number every time I'm moving along? What's the term number doing? Is it going up or going down? First, second, third, fourth, fifth. What am I just doing now? You're going up by 1, aren't you? So what I'm saying is that why I'm using that type of questioning is because every time you go up a term, you're multiplying by 1 more 2/5. So I take another one, multiply it times 2/5 to get the next one, and so forth and so on. So we do that. So let's try our multiplications again, guys. What is 2/5 times 12/25? 24 over, that's doubling. No, we're not doubling. It's 2/5 times 12 over 25. How do you multiply by fractions, guys? Top times top, bottom times bottom. Numerator times numerator, denominator times denominator. So, numerator was 12 times the numerator, which is 2. Because it's 2/5, 24. Denominator, which is 25, times the denominator, which is 5, 2/5, right? All right. Last one. Numerator, 48 over 625. all you're doing is you're taking this number and you're multiplying it times 2/5. Then you take that, multiply it by another 2/5. Take this, multiply by 2/5, and then so forth and so on. See what we're doing? All right. Sequence is defined by two-digit numbers divisible by 3. Determine the fifth term. So two-digit numbers divisible by 3. What's the first two-digit number that is divisible by 3? 12. So we're talking about 12. How do I go to the next one? What? Did you say it? So it? Say it again. You guys got to say some answers, please. We're not getting any progress if we don't. 15. How did you get to 15? Thank you. What do I do the next one? And there you go. How many more? Last one. Last one. It feels like a lot, but it is the last one. There you go. That's it. How could I write the equation here, guys? Is it a constant rate of change? Does it have a slope? Are we increasing by the same amount? Does it have a common difference? What is that common difference? Three. Guys, you did this in Algebra 1. You found that constant rate of change. You did delta y over delta of x, right? Y'all remember delta y over delta x? You got to think of it this way. Delta y is a changing of all these values that you're looking at. The 12, 15, 18, 24, which is 3. Over delta x. Delta x is how much you're increasing by term number every time. Well, how do we count, guys? How do you normally count? Hope you count by ones normally when you say first, second, third, fourth, fifth, right? Kind of crappy at the end of the year. Yeah, we got the results for a state qualifying group, and all it is, we got first is this, fourth is this, seventh is this, and 12th is this. What happens to second and third and fifth? We don't count by mixing numbers up. We just say first, second, third, fourth, fifth. So we're increasing by one number, right, every time? So that delta x, is going to be 1 every time. Yes, Josh? I haven't got there yet. Yes, and we'll get to that. So we started off our first part. We said, yes, that common difference is 3. Now we got to figure out, well, back in the day of Algebra 1, we did y equals mx plus b, right? M was slope. We determined that one's right there. What do we have left to finish this equation? What's that called? Y equals mx plus b. What does b represent? Constant's good. That's another way of saying it. But in Algebra 1 context, what did we call b? What did b represent? Y-intercept. Y-intercept. That's what we got to find here. I'm going to use those terms for now. Okay? What's true about a y-intercept when you're looking at a graph? Where it crosses the y-axis. What's true about the x value of the y-intercept? 0. Y'all follow me, guys? X equals 0. And we just talked about it. I just said that x, when we're talking about sequences, represents your term number. X represents your term number. So, number 12, or 12 right here, is that your first, second, third, fourth, or fifth term? First. What's 15? Second, third, so forth and so on. But we need to figure out where x equals 0, because that's our y-intercept. We need to figure out what's our 0th term. That's even a word. How do we do that, guys? Huh? Minus 3. If I'm adding 3 to go to the next term every time, I add 3 gives me 18. Add 3 gives me 21. Add 3 gives me 24. But if I need to go backwards, I'm going to have to subtract 3. So, that's there. I want to put a sub 0. 0 represents what? y-intercepts. Or your 0 term, right? Y-intercept 0 term. All right, let's use that. This will be pretty close to the same thing. Here we got a sequence. It says determine the, what? Determine a sequence from a pattern. So we go ahead and determine what's going on here. What are we doing every time? We're adding 3. So there's a common difference. When there's a common difference, you're dealing with a linear type equation. Okay? We've determined the common difference of the equation. Now we just got to determine, oops, not 0. What is that term? Negative 1. There you go. So this is the equation they use. It'll be given to you guys on the test and on the quiz. But this is the equation you use. This equation, I don't have time for it mainly, but this equation is the exact equation of point slope formula. All this is I take this and I transfer it to sequences, and that's the same thing. Believe it or not, it is the same thing. Believe it or not. All right, so let's go ahead and look at the next one. Example 4. You're right. We're multiplying by 3 every time, aren't we? So if we're multiplying by 3 every time, we're not looking at a linear function, that's for sure. What does it mean when I multiply 3 times 3 times 3 times 3? What's that do? Well, what's that called when we're multiplying something times itself? Exponential. Very good. Exponential is take some starting number, multiply it by some same number over and over again. That's an n, believe it or not. This is really bad. I'm not happy with this. Take some starting number, multiply it by the same number, n minus 1. I'll show you why it's n minus 1 in just a second. What's the number we start off with, guys? What were we multiplying every time? And there's your equation. Common ratio. Common ratio means you're multiplying or dividing by the same number. This one has a common difference, linear. Common ratio, exponential. Let me explain to you why it's n minus 1 real quick, guys. If I start off with the very first term, so a sub 1, n is equal to what here, guys? So in order to get the first term, I have to have, remember, this is my first term, isn't it? This is my first term, isn't it? In order for that first term to be there, it needs to be multiplied by what? 0 makes it 0. 1. If I have a number, I have to multiply it, guys, because you're going to have to keep a multiplication there because we are talking about exponential. You can't add anything, you can't subtract, you can't divide. So we have to multiply by something over and over again. Okay? Sebastian, can I see something else on the top of your head? Thanks. So what we have here is, first one is there. So what has to happen is, I need to multiply this ratio, this common ratio, by 1. How do I make an exponential equation equal 1? Make it 0. So when you're doing exponential, guys, and dealing with them, 99.9% of the time, you're going to have the power to the n minus 1. Because you always got to get that first term first, and that's there. And now what you say is this. Okay, I'm going to take that and multiply it by that common ratio every time. So now it's 3 times 3. Then if I go to the third term, 3 times 3 times 3. Some of it's a little bit confusing because I don't like the fact that the first term and the ratio is the same number. Not a very big fan of that right now, but you're about to see it differently. But this is the idea. 3 times 1, 3 times 3. Because what's 2 minus 1? 1, which means this ends up being just one time. This ends up being 2 times. 3 times, 4 times. Now it's 3 times 1, 3 times 3, 3 times 3 times 3, 3 times 3 times 3 times 3. See what I'm doing, guys? So, it's hard to see sometimes because they're the same, but you get the idea. All right. If you don't, you will now. Soon. All right. So let's go ahead and find the general term of sequences. Write the rule. All right. So again, dealing with fractions. So let's treat them separately. Don't deal with fractions as numerators and denominators for the most part. Sometimes it's easier just to separate the top from the bottom. Deal with the top, deal with the bottom. What's good about the top every time, Darcy? I waited till you got a big bite until I asked you a question. Adrian, can you talk? Okay. Adrian, what do you think here? What's true about the numerator here every single time in this series?
I think it's the same.
It is. It's 4, 4, 4, 4, 4. He thought correctly. So the idea is if I was to draw a rule of this, we're looking at it being the same on top. What about the bottom? Every time, isn't it? So multiplying by 1/3. So that tells me something here. I have to multiply. There's no adding this. So I have to multiply. The top's being multiplied by 1 every time because it's the same thing. And the bottom's being multiplied by 3 every time because we just established it's multiplied times 3. What's the first term? 4. 4. No, just literally write the first term. Four thirds. It's the first term. It's 4/3. So it's your first term times that common ratio raised to the n minus 1 power. So you're looking at, for general form, maybe something like that. And that equation will be given to you. Is your first term times your common ratio times the n minus 1 power. What about the next one? Both top and bottom are being increased by 1. However, they don't have the same starting point, do they? So that's why, again, it's always a good idea to maybe treat them separately. Okay? So if that common ratio is 1, I'm going to write it just so you can see it. 1 times n. If the common ratio is 2, it would be 2n. If its common ratio is 17, it would be 17n. Okay? So, we do what we did before on the common ratio. We said, okay, what's that 0 term? So I'm starting off with 1, and I'm adding 1 every time. Starting with a sub 1, what's a sub 0? 0. Y'all see that? Now it's 0, 1, 2, 3, 4, starting with a sub 0. This is a sub 0, a sub 1, a sub 2, so forth, so on. All right. What about the denominator? Same thing. Is it 0, though? It's 1. I'll clean that up. So it's n over n plus 1. 1 over 2, 2 over 3, 3 over 4, 4 over 5, 5 over 6, 6 over 7. Just going to let you repeat. All right. What's the next one? Next one's a little bit trickier. Is there a common difference? Yeah, so you think it's like, okay, it's being added by some pattern is there. Josh sees some pattern. He's like, yeah, it's added by odd numbers every time. So, say again. How about that? This is what's called a second common difference. Second common difference. So if there's a second common difference, then you're doing this. It's called a quadratic. If there's a second common difference, then it's a quadratic. So we do the same thing as we did before. If we're adding by 2, so what do I need to do here? Subtract 2 would give me what? 1. Which means I need to do what here? Make that subtract 1. Good. So, if that's hard to do, which it is, sometimes it's confusing to see that, maybe you say this. Hey, let's plug in 2 into my squared. What's 2 squared? 4. What do I need to do with 4 to make it equal 5? Add 1. Okay, let's try and see if that works. Plug 5 in. What's 5 squared? No, not 5. Plug in 2 because it's the second term. What's 2 squared? 4. What am I doing wrong here? I'm confusing myself because I'm using the, let me do this. A sub 1, A sub 2, A sub 3, A sub 4. Look at the term number. What is 1 squared? 1, what do I got to do with 1 in order to make it equal? Add 1. Thank you. So we're plus 1, right? What do I do with 2 squared to make it equal 5? Plus 1. 3 squared plus 1, is that equal to right? 4 squared plus 1 is equal to the next one? Okay, sorry. A little slow traction on that, but finally got it. You plug it in. Plug in your term number and see what it takes to get you that y value, or get you that certain number. Plug it in. What do I have to do next? Because there's going to have to be some number on the end here. There's going to be plus or minus something. So you go from there and see what happens, okay? All right, so now let's look at the next one. 2, 4, 6, 8, 10. What are we doing? 4, 5, 6, 7, 8. So common difference means 2n over 1n. Go 1 back on top. What is that going to be? 0. Go 1 back on bottom. What's that going to be? 3. There you go.